Yeah, hello. Welcome to this next session where we invite you to hop on the high performance computing highway with CSU San Bernardino. Thank you for attending, and I'll throw it over to these guys to introduce themselves.
Thank you, Nick. Good afternoon, everyone. I'm Sam Sudhakar. I'm the Vice President and Chief Financial Officer at Cal State San Bernardino.
Good afternoon, everybody. I'm Youngsu Kim, an assistant professor of mathematics and also serve as high performance computing faculty fellow.
Good afternoon. My name is Dung. I am HPC consultant. Thank you.
So welcome to our presentation. The main idea behind this presentation is to demystify the myths that exist about joining the NRP. And hopefully at the end of the presentation, you will know how to join the NRP and how to make this available to your faculty and your students at your institution. So starting with the vision of Cal State University San Bernardino, we're located in San Bernardino, and our vision is to transform lives of our students, faculty, and staff. And we do that in multiple ways. And today you will see one aspect of how we transform the lives of our students, faculty, and staff who come to Cal State San Bernardino. So what we call in CSU is faculty-led research. Faculty are at the core of our institution. They are who the students come to see, and faculty are the ones who make the most impact on the students who come to Cal State San Bernardino. And at every level of our institution, we realize and we profess and practice the fact that faculty, play a very, very important role in the transforming the lives of our students. We are one of the top 5 institutions. We punch above our weight in many instances. There are much larger CSUs that don't do $44 million in federal funding every year. We received a Research 2 designation in 2022. Most of the funded research projects did not require high-performance computing back in 2015. And the reason was that we didn't have access to high-performance computing, so faculty didn't really go after research that required high-performance computing. When there was a handful of 2 or 3 faculty who required high-performance computing, and they went to other resources outside of the institution to get resources for HPC. So back in 2015, I did a tour of the institution. I was, at that time, the vice president and CIO, really taking care of the technology portfolio. And I wanted to meet with our faculty members to find out how we can support their discipline-specific research. And as I met with faculty members one-on-one, they said, well, IT doesn't do that. IT is just an ISP. You guys provide the network and all these software resources. You guys don't support, our discipline-specific research. And I said, that's what we want to do. We want to support your discipline-specific research. And that was an eye-opener for our faculty, for an IT person to show up in their doorstep and say, we want to support your discipline-specific research. And when I finished that tour, what I found out was we had a great need for high-performance computing from a handful of faculty, and several faculty expressed the need for HPC, but they didn't write grants that required HPC because we didn't have HPC, we didn't support HPC at our institution. So we took a handful of faculty and we built an HPC cluster with some old servers that we had retired, and that was our journey into the whole HPC world. As soon as we started offering these HPC resources to our faculty, the need started to grow dramatically, and we found out that we really couldn't support the need of the faculty with what we had on our campus. So we had a library dean who brought Exceed, and now it's Access, to our campus to talk about how Exceed can support our faculty-led research. And a handful of faculty hopped on it, but Exceed really didn't support what they needed. So we ended up buying HPC resources from the San Diego Supercomputing Center. And since I was so focused on supporting our faculty led research, and I gave them my word, we actually paid for the SDSC supercomputing resources at that time from the IT budget. So we started gaining that credibility from the faculty community. And during this time, what happened, I went to an Internet 2 conference in Chicago, and I met Scenic President and CEO Louis Fox, and I started talking to him and saying, we really need high-performance computing resources on our campus. And he and I engaged in a very meaningful conversation. He says, why don't you experiment with high-throughput computing through the Pacific Research Platform? And I've never heard of the PRP before. And I said, what is that? And Louis explained to me how PRP works and all these institutions that were involved. So I got all excited. I came back and talked to my team, and I said, we really need to join PRP. And then they said, well, you got a 10 gig connection to the internet right now. So how can we join PRP? We're going to be throttled at 10 gig. So I contacted Louis and I said, we need to increase our bandwidth. And at the same time, we were moving our resources to the cloud. Many of our resources that were on-prem, we were moving to the cloud for DR and high availability, et cetera. So Louis and I started working. I joined the Scenic board in 2017, and we slowly started increasing the bandwidth from 10 to 20 to 40 gig connection, and we did redundancy, and we were ready not only for cloud computing, but also for joining the NRP. And I asked Louis, how do I join the NRP? And he said, just send an email to Larry Smarr. That's all it takes. And I was like, wow, it can't be that easy. So I emailed Larry Smarr. I said, Dr. Smarr, we want to join the NRP. Immediately, I got an email from him saying, you're in. So this still exists. So if you are sitting here and want to join the NRP, just email Dr. Smarr, who's right here. So, of course, the PRP and now the NRP is a partnership of more than 50 institutions led by researchers in UC San Diego, UC Berkeley. I mean, for an institution like Cal State San Bernardino, I thought when I email Dr. Smarr or somebody, they'll be like, who are you? You're like Cal State San, who has even heard of San Bernardino? But the reception I got from Dr. Smarr and then from Tom DeFonte and others was just so encouraging. They're like, okay, come on in, let's see what you need. And then so here's Dung, and he's like finished his PhD at UC Riverside in computer science. And he's like, I want to do something with high performance computing. So we talked with Dung and said, Dung, do you want to take on this? And he's like all excited. So he started communicating with Tom and all the tech folks behind PRP. And one thing about Dung is he never gives up. He's so persistent. And Tom can attest to that, right? So Dung was like, we need this, we need that. And then we started looking at science drivers. And that's how we got started. Just half time. Dung was not even dedicated full time towards high performance computing. So we started supporting all these small number of faculty members. Then we realized we needed the translation of these resources between the tech folks and the faculty community. So, Dung is on the tech side. We needed a faculty member to really bridge that gap. So we put out a call and we attracted Dr. Youngsu Kim, who's an associate professor of mathematics. And he not only understood the technology behind the high performance computing, he knew how to translate it into faculty language and made faculty feel very comfortable about working with him. So he started doing his road trip among the faculty community, and that's how we are today where we are. I mean, using the PRP resources to the amount we are using it today. So a little bit of a history. We constructed the Science DMC in 2017. Dung attended the this Scenic conference in 2018, where they talked about the Fiona, and he attended the workshop. And and we upgraded our backbone to 100 gig in 2018. So a lot of things had to happen, but they all fell in place because we had the thirst, we had the need to hop on the HPC highway. Is this yours or? This is my last. Okay. So this is how the architecture looks like right now. And it's as easy as I mentioned. There's not a lot of elitism involved in the NRP. There's not a lot of, oh, you're not Stanford or Berkeley to come on the NRP. You could be Cal State San Bernardino, you could be a community college, you could be a K-12 institution. And what NRP has done and the team led by Dr. Smar has done is really democratized the availability of NRP to all students in California. And all you need is the willingness to do that. You don't need a lot of resources. Right now it's just Dung and Youngsu, who are doing that. And we got the grant with Dr. Mary Thomas. And, we got 2 grants, in fact. Thank you, Dr. Thomas. And, now we're getting on the map. We're getting other CSUs involved. So our goal is to get all the 23 CSUs involved in the system. And as Dr. Smar mentioned this morning, 60% of all the undergraduate degrees that are produced in the state of California is from the CSU. So we are a big institution, largest public institution in the state of California, make an impact. We transform the lives of our students. So why not make NRP resources available and AI resources available to all of our students that we graduate? 445,000 students currently enrolled in the state of California in a CSU. So come and talk to me if you need any other information on how we joined the NRP. It's very easy. It might not be as easy in the next 10 years, but today, Dr. Smar is here. So I'll turn it over to Dr. Kim.
Yeah, thank you very much, Sam. Let me take it from here. So our high-performance computing team consists of 5 members. As seen in Sam's part, Dung and James started with the Fiona machine a few years ago here at the Scenic meeting. Currently, James is playing another crucial role on campus, and Dung and I have mainly served our HPC users. There's also an administrative side of the game. Gerard, our CIO, who is here. Also, Brad from the academic side has tremendously supported our HPC program. Then the natural question is, when you see this one, where is Sam? Well, as Sam said, he was our former CIO. Now he is our Chief Financial Officer and Vice President of Finance, Technology, and Operations. Since his title is getting longer and longer, we decided to add him invisibly to this slide. However, it's indisputable that his enthusiasm, vision, leadership, and continued support have shaped our current HPC program. As a result, we have multiple HPC sources, including 3 top-tier providers. The National Research Platform, our primary provider and supporter, consists of over 300 nodes distributed nationwide. Indeed, last week was the National Research Platform meeting week, and we had a lot of fun. I would like to reiterate the phrase I learned from the meeting. I think it was Frank. These resources listed on here, they never ask for your credit card numbers. In addition to the National Research Platform, our users have access to Open Science Grid, specialized in high-throughput computing. Furthermore, Access, formerly Exceed, is a gateway to multiple supercomputing centers nationwide, including Indiana University JetStream 2 and our longtime friend San Diego Supercomputing Center's Expense. As a CSU university, our primary mission is education, to provide high-quality education. In addition to engaging with students in the classroom and lab, faculty must conduct research. My colleagues' excellent work shines in on all disciplines, and it's not surprising to see their results and their work in HPC-driven areas. Well, I also want to note that several projects listed on this page and in the CQO are conducted with our undergraduate and graduate students. The first page contains projects from more typical users we expect in the STEM disciplines. This number is steadily growing. This page has projects from our business school and one from our history department. The information and decision sciences department is one of the most active departments on our campus, and their projects are often closely related to real-world problems like sleep apnea and short-strip drone path problems. We are going to see our history professor, Kate Liska's project in detail soon. We hope to recruit broader groups of users since our HPC resources are for everyone on our campus. In addition, we have been building close relationships with on-campus research groups, and we support their research and workshop with our HPC resources. Okay, so let me share some of the research project that's done using our high-performance computing resources. So the first one is my neighbor, Sudha. He and I work in the same department. I'm a mathematician. He specializes in statistics. So this goes back to early 2000, spring 2022, March. Well, while we were talking, I already knew that we could run his program, RStudio, on the National Research Platform. But at that time, I did not have an explicit example. While we were chatting, while we were walking to the parking lot, he told me he was running 3 simulations. After a week, he hasn't gotten any result back. So I suggested him, why don't we test it on the NRP network? And he graciously shared his code with me. That night at 10 p.m., I submitted the work. And the graph you see, maybe it's kind of hard to see, is showing that we were utilizing over 200 cores and over 200 gigabytes of RAM. For your information, nowadays, most mid to high tier personal desktop computers have 8 to 16 cores with 32 to 64 gigabytes of RAM. Now we support Sudha and his student via RStudio on Jupyter Hub. This approach provides uniform platform that is also reproducible. Well, next one is my story. About a year ago, I met a friend from college. We are both mathematicians. We work at 2 different universities. We wanted to do a certain project together that would also benefit us and our students as well. So we started something called arithmetic progression. So we're really looking for a triple that satisfies some condition of an equation. I knew at that point some Python. I tried a small example with Python, and we got some promising early result. Python is powerful and great and easy to start with, but without a dedicated package, it can be really slow. At that time, I was also participating cyber infrastructure professional training led by Dr. Mary Thomas, who is also here at San Diego Supercomputing Center. They helped me tremendously in several different artificial intelligence and machine learning, but at the same time, they gave me a chance to refresh my coding skill in C and upgrading skill. And they also helped me to get on board with OpenMP and OpenACC. I should also mention the names of my mentors, such as Andy, Bob, and Rick. What these OpenMP and OpenACC do is you can leverage multi-core and GPUs without getting your hands dirty. Well, on Christmas weekend, I was really excited. And actually, let me show you the graph first. After with the initial thing, if you see the graph, the dots on the right, if you're a mathematician, you're gonna get really excited. But if you're normal people, you might not see anything. So when we saw this one, we got very excited. That must be something close to a line. At that time, we were able to analyze the one out of one, and we wanted to see what's happening in the rest of the world. So we already proved there exists infinite many integer solutions to this, and we wanted to study more. In order to do that, I needed more data. So I was waiting until the Christmas break, and last year Christmas was on Monday, so Friday night I was determined I'm going to submit as many jobs as possible without disturbing people at the NRP because that might be weekend. Okay, so the graph on the right, you see that I was able to utilize over 100 GPUs simultaneously, and all of them were running more or less 100%. With that, I was able to get really, really far with the result. So I could run triple up to little over 2 million. Okay, I do not often have a chance to share my research, but this is a great opportunity to thank my campus for providing the HPC resources that opened another avenue in my research. I'm very positive other faculty members feel the same. I also would like to thank the National Research Platform and San Diego Supercomputing Center for providing the resources and the Cyber Infrastructure Professional Training Program. And I hope to share my knowledge with our campus members or other campus in California. Okay, let me move to another research by one of my colleagues, Kimberly Cousins, in chemistry and biochemistry department. Well, in this particular study, she is modeling functional organic organometallic compounds. Simulations aid their studies significantly, but require an intensive level of computing. Recently, she wanted to explore a package called Elastic VASP, which allows certain calculation by variance of a single setting, but the number of variants would be 21 out of 1. So the package's sample script was serial, and she told me that based on her testing case, it would take 30 days to finish. I suggested running them simultaneously as we had access to a plethora of HPC resources. The image shows that half of her job simulations were running concurrently. If you look at the top one, at one point, her simulation that they were using over 10,000 CPUs at the same time. Well, and everything combined was finished in less than a week. And working on creating a workflow to better suggest her research, better support her research. Okay, so next one is our history professor, Kate Liska. Well, it's last but least, it was our inaugural and initiative project. Indeed, this project started even before I joined our HPC team. Her group visited several sites in Egypt and reconstructed them in 3D image based on over 90,000 still images. So the project, I think the site is called Wadi El Hudi Expedition, and you can find it on their webpage, and we have a link from our HPC webpage too. They use Metashape as a software to process those images. And on the next page, you can see some of their product is really nice. Look at how crisp the letters are. All I did was took that photo and zoomed in, and you can see the letters and clearly read what they are, if you know what they mean. All right, so they have been our precious example in non-STEM discipline and a pioneer in the HPC research. Of course, we support classes. At the beginning, most resources were for research only, and we wanted to find a way to expand it to the classroom. Dung, who is my co-presenter, and Larry from NRP, they inspired us a lot. So with their support, we were able to expand it to classrooms. Well, all these things, most of the classes have their own dedicated Jupyter Hub, and instructors are the admin of each Jupyter Hub. And they do not need to create additional credential or account to log in, thanks to CI login. Well, here is an example of the front page from Biology 5050. And this was done by Dr. Bree Putman from Biology Department. The reason I have this page over here is that if you're an instructor and if you need to use your HPC resources in the classroom, the thing that's very frustrating when you try to grab resources, they may not be available. So I tried to say this phrase last week. I totally failed, but I practiced over the weekend. So HPC in need is HPC indeed. So we needed to find a way to have all those resources ready for students. So what I did in help with the instructor was we wrote a script. So all students' server would start half an hour prior to each class meeting time. So when students walks into the classroom and they open their browser, their software, in this case, RStudio, is ready in less than 5 seconds. And thanks to the class for bearing with me through the process. Well, here are the numbers we use by, all as a result of all this collective effort. But they are important. But in my opinion, I want to say this is the outcome of our effort to democratize the HPC resources and collective work of our campus members, faculty, staff, and most importantly, our students. That's all I have for today. I'm going to pass it to Dung. Thank you.
Thank you, CNET, for allowing us to share the experiences we have with HPC computing. So, how our campus provided HPC resources to faculty. First, we through the meeting, through the demonstration, we introduced the HPC resources and what the HPC resource can do, the software they can provide it, the free resources from HPC allocation and NRP. So when we know the faculty has interest in HPC, we approach and then learn what they need. Then we install the HPC system and test it, make sure it works. And also we make sure that the resource is available and reliable and stable for the software to run until it's finished. So we take the serious responsibility to ensure that the faculty will successfully complete their research. And then giving up is not our option. So before we present how we deploy Jupyter Hub in our campus. For us so far, Jupyter Hub is the best, is the most efficient, and is a scalable approach to provide everyone to have access to HPC computing. So for example, I want to demo that, for example, I'm a student. I would like to access the HPC to do my homework, to practice from home, from coffee shop, from whatever, using the browser. So it here is when we click at the link from our HPC campus of the student HPC, student research hub. So we log in, right? For example, in here, so in our campus have a collaboration with other campus. For example, some collaborators, some student, the other campus would like to practice in our campus. We provide them the IDP access. So for example, you can choose the Riverside, San Diego. So for example, I choose mine. Okay, good. That's ready. So I log into. So I log into my IDP, my campus IDP. We don't have internet. Check. So you log in my two-phase authentication. So I log in before it maybe go through. So we see here, a student, I have an option to choose any Jupyter stack like the software I want to practice. I can go either the basics, minimum is like simple Linux operating system, or you can use the data science package. So you can choose any option. And in here, we also have the stack that design that developed by own team. For example, this one is designed RStudio. We have RStudio from RP, but the professor, they would like additional R package to be added to RStudio for and then Dr. Kim Youngsu assist to modify the code and then deploy. So for example, I would like to go with the stack RStudio, right? I go with this one. So after the server has been configured, now I run with the standard one. So the server started, and then I can practice as student. I can practice the RStudio. So as you can see here, this is from the Jupyter Hub. We go with the Jupyter Lab. And from Jupyter Lab, you can choose any Jupyter node we want to run. For example, we run the RStudio here. Right. So RStudio, at the time we deploy, we don't have anyone free yet. Everything is commercial, and then we have to pay for that. Students have to pay for that. So with this one, student can practice RStudio with the GUI interface. Very convenient. Without students don't have to pay anything. They just log into the system and then practice the RStudio. This one is very, very important for their data analysis and data science. For example, I can show how is the graphic GUI work. I think I ran before. It should be working. See here. So the student then produce a plot graphical result for the class, for the course. And then it doesn't matter how many students they need to practice. Everyone in the campus, everyone in class and practice. That is the powerful of the Jupyter Hub that powered by the NRP. So I would like to take another one like the machine learning that I took from Dr. Thomas and on the SDSC. So now I would like to, I don't run this one anymore. I shift to another program. So I need to log off, right? And log off. I stop the server and then I start a new one. So now I choose the TensorFlow plus PFP package. This is the TensorFlow modified by the NRP scientist, and then to make it in the available repository, we just pick it. We just pick it up and then put in our Jupyter code and then launch it. And then I run from now here. I forgot. Actually, I can choose the GPU to improve the performance, but I already choose the standard. But should be okay. The TensorFlow can run faster if we use the GPU, but now we just use standard is the CPU. I can run the GPU later on. So we are different server, different software. So I will run, I think I will choose the one that I studied before with the SCSC about the machine learning. So I'm glad to run one is the CNN convolution network. So now we have here, right? So let me run it. I clear on the outputs and I start to run. I can run from top to bottom, but I'm going to run one after another to see how it goes. See here? It says a warning that some before is not the way they think, but I continue to run. So they configure the model, right? And then it is not the model they already configure, and they run this one. This software is to using they using the modified National Institute or Library to detect, to recognize the number. So I can run it for a training, right? The training process. So it means that students, they can practice, they can learn machine learning from home, from anywhere, using the NRP stack. Yeah. So I think I can run now. It run now. So I continue some step more. See here, the training and also see here, that is the code from the AI ML we learned from the SDSC in the last summer. So now it's okay. I can shut it down. Actually, this one is for student, so it will automatically shut down when the browser is closed for 30 minutes to conserve the resources. So I can cut it down. I stop the server. So now I come back to my presentation. I'm sorry. Let me see a second. I think okay. I think I close it. So come back to my presentation. So how the Jupyter Hub was developed and deployed, and how many Jupyter Hub available in our campus right now. So we design and deploy Jupyter Hub based on the use case. So we have a 3 use case. First is student. Second one is for faculty. The third use case is for dedicated research group, dedicated projects. So the first use case is Jupyter for everyone. So with this one, we limited the resources because it's a student practice. So we start from 4 core, 60 gig per RAM until like a 28 core, 64 gig per RAM. And then we have maximum 3 GPU. So with this one should be sufficient for students to practice. So how we deploy the Jupyter Hub? We use the NRP GitLab. This is one of the most popular developed platform that is integrated with the NRP cluster. So we deployed the Jupyter Hub with the Jupyter Stack we need, and then it will instantly deploy in the NRP cluster. Not only that, the NRP have a so rich Jupyter library, like the function like this here. We just use it. Actually, this library has been developed by NRP scientists for last several years. I would like to mention that it is Mr. John Graham. I don't know he's here. Dr. Dimitri. He developed very rich software, Jupyter Hub, and a lot of code for the user, for developer like us to use it. And also, and also the Jupyter Lab event very convenient in a way that it helps us to deploy our own container. We don't need to use any separate software. We just use the Docker file, and then it created the container and then put it in the repository for us to use it for our own need. Right. Beside that, we have the excellent technical support guy and very dedicated scientist, I can say. It's available anytime. And then I can ask a question at night. It should be not abnormal times. So that is the reason why we are able to deploy Jupyter Hub for our campus. The second use case is the Jupyter Hub for research. This one is dedicated for professor, for the researcher. They want to do to run some application, some stack, some Jupyter stack that need a lot of resources. For example, big number of score, large number of RAM, and high-end GPU. That one is available, and then we try our best to satisfy that. And then NRP provide tremendous support by allocated the dedicated node. One is very strong GPU node, one is very strong CPU node, so that the faculty can configure their server run up to like 256 core, 1 terabyte of RAM. So with that kind of resources, the program can be finished. And then there's another thing is for this hub is run uninterrupted. Even some program run for weeks, and then the faculty member, they does not need to close the browser. They can close the browser and they come back to check the day or two to check. The program's still running. It never shut down. So that is the second hub. The third Jupyter category is the Jupyter Research Hub for dedicated research group for a project. Some professor, they want a research hub for their own. They don't want the other outside of their group to access. And then some project, they need a special storage, special size, special installation. And then some data they don't want to share with anyone except in their group. So we satisfy their request. So we deploy a single research hub for specific project, for specific professor faculty if they need it. And actually, it's a good point that it avoids the single point of failure. Because when we have multiple research hub, one process hub is some die, we still have the other research hub still serving the faculty. So far we have over 10 dedicated research hub for our campus, and then now we have 14 AI ML project registered with us, and then we are going to deploy more hub for them. So we just have the big grant of like $1 million. So we have like 26 compute nodes at SDSU. We are excited. We are very thrilled that we no longer, I email the faculty of CSU, professor, I don't think you would be worried about the resources because we have it. So our campus have a couple of ongoing research and couple of publication as result of the using NRP. So the future work, we will promote HPC awareness in faculty and expand HPC support to research to all academic domain, not only computer science, archaeology, chemistry, all other department. If they need research computing, we will proactively approach them. And then we expand support for HPC related courses, which is, and then the growing resource, because I believe that is the way we help our students accelerate their skill, which is very needed. Second one, we will collaborate with the CSE faculty and SDSC and also NRP to provide AI ML support, because AI ML already involved in many research aspects that I don't think we have enough knowledge. Frankly speaking, we need to learn and then use the other for our faculty. So acknowledge. I think today, I don't want to say again and again and again, but we would like really thanks NRP. We thank Dr. Smart, Dr. Defanti, because without their vision, we don't have NRP. We don't have JCI. We don't have the NRP. And also to Mr. John Graham, Mr. Dimitri, and then the NRP technician scientists. Without them, without their dedication, we don't have the running research hub. Never. So thank you, everyone. Thank you.
Well, thank you guys so much for sharing your journey on deploying the high performance compute. I think it's very helpful for people in here. We have a few minutes left. I think we can open it up for some questions if anybody has any. We can run the mic to you, or you guys can come up to the mic.
Hi, my name is Ceci from Cal State Fullerton. For the courses that you offer HPC support for, what is the engagement from the faculty, the training, learning curve for the students, and how much technical support do you provide?
Hello. So my perspective, faculty do not know anything about HPC at all. All they need to know is resources are ready for their student. And whenever their students have any difficulties, they can contact me directly and I'll step in, resolve their issues. And of course, they're open to learn more if they want.
Hi, thanks. What, if any, cybersecurity concerns do you have with the HPC deployment? And what did you do to address them?
Hello. We are very concerned about the security. 2 weeks ago, actually last week, 2 students, they run this one and then they run the Bitcoin mining. We found them, and then we banned them from the HPC resource. Maybe after a few months, I lift the ban, but let them know that we know what they are doing. You know what they are doing. And then we closely monitor the resource usage to make sure that they are not abused. And then if any problem of any server, we know before they contact us. So yeah. Okay.
So I just wanted to follow up on that and just say that the systems administrators, the cluster administrators have extraordinary visibility into what people are doing in the system. And if you looked over Dima or John's shoulders at any given moment, you would see they're constantly monitoring. And we can tell when a project is pulling down software that might not be so good for the community. And it's It's community policed. So I have wholeheartedly bought into Nautilus and NRP at UC Santa Cruz, and I have no qualms whatsoever about recommending it to our researchers. And I passed the smell test with the security people. So I don't have any concerns as long as we can keep doing what Dung said, keep an eye on our students.
If I can add one word about the incident about Bitcoin mining, they were not smart enough because they were using CPUs instead of GPUs. So yeah, but that's actually concerning because we have been focusing on expanding our services. At one point, we're going to see more users like this. They just do it for fun or just wanted to test it out. But there are security measures we can put on, and we can put a little more restriction each user without maybe destroying accessibility or decreasing accessibility and liquidity. So, but this is something to think. That's very question.
I thought I saw a slide up there where you guys, when you first started using the system and there was a cost associated with it. Is there a cost associated with it? And there was a slide to show some calculations.
So far, the cost has been very minimal for our campus. Most of the resources that we have got are from the NRP, and if there's any cost associated with, we do host a node in our campus, and we provide the ping power and the pipe for that particular node. So other than that, it's a very economical way to get into high performance computing.
Actually, I had one I'd like to bring forward. Can you speak a little bit to some of the reactions that you've gotten from like faculty and students after they have access to these resources that they didn't have previously? Yeah, just speaking a little to that.
Yeah, absolutely. This is something that it's changed shift of paradigm of what IT can provide our faculty community. This is something that the traditional IT in CSUSB never provided. And as we talked to the faculty members and found out, and faculty are very passionate about their discipline. And if we're able to enhance their research, their discipline-specific research with these kinds of resources, faculty are very open to it. And we had to establish the credibility among the faculty community for the first 2 years. We told them what we can do, and we supported them with what we could do. And now, it's a very established platform in our institution, and faculty are not afraid to come out, seek help in their projects. And Youngsu as well reaches out to faculty for more faculty to hop on the platform.
Yeah, I wanted to build on what Sam was saying in terms of how we move this out among other CSUs. Why don't you talk a little bit about the showcase events you've had? Because I think having given a talk to that and participated in that, making an invitation to a lot of your CSU brethren and sisters campuses to tune into even virtually. I think it's so powerful when you see the actual researchers explaining their work and showing how they used it, and how I'm a researcher, I'm not a computer geek, and I got onto this easily, and I used Jupyter, and I did all this. I mean, I think you have a much larger potential audience for these showcases that could be very effective and sort of the horizontal spreading, that Frank Wertheim talks about. And again, we don't have a lot of time in this country, given the challenge we have internationally. So what would it take to do that? And for instance, could CIO Ed Clark of the CSU system, could he help, even lead something like that, a virtual session across the CSUs? Is that something we could imagine in 2024?
Absolutely. So, Ed Clark is committed to spreading this resource across the CSU, and we will definitely be behind him on this effort. In fact, we're going to have a meeting of the minds in the next couple of weeks to see how we can apply for a system-wide, CSU-wide grant, tight grant that will bring this resource and training to all the CSU campuses. So as Dr. Smar mentioned in his presentation, we went from 8 to now 12 institutions, and it's a matter, we have the critical mass now. So it's a matter of bringing the other institutions, and it's the fear of the unknown and a lot of misinformation that's preventing those campuses, and we will demystify those in the coming months, and hopefully by the next CNE conference or even the next NRP, all the 23 campuses will be doing something with the National Research Plan.
So this is Ceci Calthe Fullerton again. So we're already, kind of onboarded. We've made a connection, and this is a great forum where we've learned. And I know that, Willie here is also trying to get us, all set up. So definitely going to be actually preaching this to the other CSUs as well.
Hello. Actually, to build a Jupyter Hub, it could be it take time. You can do very fast, and then in fact that we don't need any infrastructure in your campus because this node it runs somewhere in the SDSC. It's no need to be in campus node. So among 300 nodes, Kubernetes can deploy your server wherever a resource is available. You don't need any infrastructure in your campus. It's just the code deploy and run. So that's why you can deploy. You can start the research computing assistant in your campus as soon as possible.
Cool. Well, thank you so much for sharing your journey, and I'm sure there'll be questions and people can follow up with you directly, but thank you.